Welcome. So previous class I was discussing about of that models. We seen that three models. First model is Cram's model, where what is see in the Cram's model, that if large groups is seen to carbonyl groups, then attack it from the medium group side. That reagent will attack from the medium group sides. And if for that Cram's chelate model, or it also called that anti-Cram's model, for that we look the chelate groups, and if the chelate groups seen to this carbonyl groups, then attacking of the reagents will be the from small group sides. And comfort model, instead of these chelate groups, if halogen group is there, halogen also a chelate group, but that halogen, this comfort model is specifically for halogens. If halogen there, then that is anti to that halogen group is anti to this carbonyl, then attack it from the small group side. That reagent will attack from the small group side. So we can remove it by this Cram's, anti-Cram's and comfort orderly. You can look it, and that we say that syncyl anti, and that is medium small small. Okay, so we will use this to solve the problems. So we were discussing the problems of it. Now we will solve from past. So these questions, okay, for past questions, what you see that here carbonyl group is there, and to this alpha carbons the stereochemistry has mentioned. Okay, so if stereochemistry is mentioned alpha to this, then we will look that either you use Cram's model, anti-Cram's model, or Comfort model. Okay, for Cram's model, what we say that large group we will look, and that large group has to be that seen to this carbonyl group, then attack it from the medium group sides. And for Cram's chelate model, that alpha carbons, there has to be a group which is where unsaid lone pair has to be there, and that metal that is used, that should show the chelate properties. So here lithium is there, metal, and it shows that chelate property. So there is a possibility of the Cram's chelate model, but the problem is here that here this Bn2 what it says, Bn2 means this is here N2Bn2 is there, that is CH2, and this is phenyl groups, another is CH2, and this is phenyl group. So Bn2 meaning that is benzyl. Okay, and this is attached with nitrogens. So this lone pair is surrounded by a bulky groups. So due to this bulky groups, because two benzyl groups are there adjacent to this nitrogen atom, so because of this, these lone pairs become so much bulky, and due to this bulkiness, this lone pair not able to chelate with these metals. So here that it will not show that Cram's chelate model, we will use simply a Cram's model. So what the Cram's model says that, and to this carbonyl groups, here first classify this into small, this is small, this is medium, and this is the large group. Okay, so what the Cram's model says that to this carbonyl groups, that large group has to be seen. Okay, and one more thing, from stereochemistry we know that this means always this is the left side, and this means this is always right side. Okay, this always it is in the left, and this is always in the right. So here by in the questions they have mentioned that this is in the right side, but actually this is in the left side. Okay, so this we have to remember that this is from stereochemistry, that this always it means that left, and this means that right. So that we will do here. So make this in this format. So this carbonyl groups, this is H, and this is here methyls, and this is, so left means this NBN is left, and this is right, so this is the right. Okay, now make this this large groups has to be the seen to this carbonyl groups. It means that I want this here, so that it will be seen to this carbonyl groups. So for that I will rotate this one I will rotate here, this one I rotate this. So if you do these rotations, then what you will get, this is carbonyl groups, this is H, and now here we will get this N BN2, and this methyl will be here, and this hydrogens will be here. Okay, so this is that after rotations you get this. Now what you see here, so you know that this means left and this means right. Okay, so which is the left side? Now you see that this medium group is in the left side, this is in the left side. Left means that is like this. Okay, so now what you see that after making these large groups to see into this carbonyl groups, now we will look the stereochemistry. Okay, now this left means this is back sides, and this is right means this is the front side, and we see that this is the medium groups and this is the large groups and this is the small groups. So after this large groups seen to carbonyl groups, now we will attack the reagents. That is here CH3I will be the reagents, because methyl, this is plus and this is minus, so this will attack. So this will attack in the stereochemistry of medium group sites, because if large seen to these carbonyl groups, then attacking of the reagent will be the from the medium group sites. Okay, so medium group is in after rotating this, in which stereochemistry is there, that we will not look that in the past case. Okay, this we will not look, we will look after this, after taking this large group to seen to the carbonyl groups. After that we will look at which stereochemistry that medium group is there. So here that stereochemistry of medium group is left side. Here in the past case stereochemistry of medium group is in the scene, so this we will not look, we will look that this one. Okay, so the stereochemistry of the medium group is in the left side, so this will attack to this carbonyl groups from the left side. Okay, so this is going to be, so let's say if this is the carbonyl groups, then left side will be the CH3 and right side will be the, that is if CH3 attack, then this is going to be that, then that is going to be that O minus, and after hydrolysis we get OH. Okay, now here we have this another carbon, here we have that H, this same H. Now we have another carbon, this one, this carbon. Okay, in this carbon this is methyl here, so make that same things. Here H we have, here methyl is there, and here NBN2. Okay, now what you will do that after doing this, take this into the original form where it is. So how in the original form, same things we will make that. Okay, in the questions in this format is given, so make this on that format, whatever given, the same, copy paste it, the same things, make it. Okay, so it means this will be the CH3 will be here, and H is OH is here, and or I can write here. Okay, so here I will write here is that so here will be the CH3, because you will attack that which side, this Me is in the left side, so attack this in the left side as well. Okay, sorry, I did anything wrong here. Oh, sorry, this is the right side. What this is the right side, and this is comes to the left side. Okay, so sorry, so this is the right side and this is the left. Okay, because we are here, then this is our right hand, this is our left hand, so this is the our right sides and this is our left side. So attacking of these reagents also from the right hands, from the right side. So these carbonyls, then this it attack this CH3 from the right side. So right side means these things, this will be that CH3 groups, and this is going to be the left side, that is OH. After that, here we have that carbonyl groups. You will copy paste it, whatever is there. This is H, and this same things, that is here methyls. So after doing this, copy paste these same things. So here we have that H, and here we have that BN2. So this we will copy from here, whatever the things, just put it here. Okay, this one we did for our stereochemistry. They ask the stereochemistry of this carbon groups. So we have made this. Okay, after that, doing this, after that convert into the original form of this, original format of these groups. Okay, so this is the final answers for these questions. Now we will look at next questions. Moving on to the next questions. Here that in these questions, two different reagents given. First is here, another is here. So in this case, what is there? Note that if lone pair here is also pair presents to this carbons, alpha carbons. Here phosphorus is there, to this lone bearing oxygen is there. On that case, also this lone pair able to do the chelate. Okay, so this oxygen also can do the unsaid lone pair electrons are there, so they can do the chelation. So here, but the problem in this case that the metal is here sodium, and we know that this sodium will not show the chelating property. So here that Cram's chelate model is not followed. Here that simply the Cram's model is followed, because here the problem is chelating metals, that is not there. Okay, so for this case we simply follow the Cram's model. Okay, here the problem is with lone pair. Here lone pair is no problem, here problem is with the metal. So for this case we simply follow the Cram's model. So same things we will do here. This is the carbonyl groups, and here stereochemistry is mentioned. One is here H, this is here pH, here pH, here is oxygen. So this lone pair will do the chelation. If the lone pair is here, then it can't do the chelation due to that bulkiness, but lone pair is here, so this can do the chelation. But here problem is with the metal. Okay, and this is like this. Okay, we see that this NaBH4 not able to reduce this that bonds, which is that is this bonds, this double bonds is can't reduce by the NaBH4 or lithium aluminum hydrates. Okay, so we will not reduce it, we simply reduce this carbonyl groups. So for this, what you look at, make this into a classified into, this is medium and this is small and this is the large. So since here that Cram's chelate model is not followed, simply Cram's model is followed. So what we have to do, that to these carbonyl groups, make this large group seen to it. Okay, so also we know that this means always right, this means always left. It means now I bring these compounds, this. Okay, so this is always right, so I will make this here CH3 is there, so this is always right. Right means here, that is this, and this is pH, here dot, and here pH. Okay, and this is left. Okay, that I did now. So that stereochemistry of this carbon already done. Now what we will do, that make these large groups seen to these carbonyl groups. For that, what I have to do, that just rotate it from here and bring this here. Then what you will get, so rotate these groups P, pH and pH, and here we will have that CH3, and here we have that H groups. Okay, so now the rotation is completed. Now what you see, that this is the large groups and this is seen to this carbonyl groups. Now that attacking of the reagents from Crumb's model is, if that large group seen to carbonyl groups, then attacking of the reagent is from the medium group sides, and this medium group side, this is in the left side. Left side means, left means that is this, that is below sides. So attack the reagents from the below sides. So here this will be the below sides, means here I will attack that reagents. The reagents here is that is this reagents NaBH4, also the reagent is H minus. So attack this. H will be this side because this medium group is in the left sides. Okay, and this OH will become the right sides, and it is simply here this CH3, and here is H, and here we have P, we have here pH, here pH, here this is double bond. Now after doing this, make this make these carbons to this original forms. Original form in the sense, make into the same copy paste it. Okay, so after doing this, change this to the original form. So that will be like this. This is H, this is OH, and here CH3 is here, so CH3 is here, and here we have H, and in this side we have this P, pH, pH, double bond, double. So this is the final answers for these questions. Okay, because here due to metals, this is not so the chelating properties, so you will simply do the Crumb's model. Now moving to the next questions. This is if NaBH4 and CeCl3 is there. Okay, with that this is the solvents and minus 78 degrees centigrade. On that times NaBH4 will not show the chelating properties, this Na metals will not show the chelating property, but we see that Ce2 plus this show the chelating property. So whenever NaBH4 with that this reagent is given, on that time it will show the chelating property. So here we will do the Crumb's model. Here Crumb's chelate model. So if I do the Crumb's chelate model, for Crumb's chelate model, what it says that this group has to be the syn to this carbonyl groups. It means up to this it's same. So now I want this to the syn to this carbonyl groups. So yes, obviously this is also a large groups, always, as well as this is also a chelating groups. It means that same answers you will get. Okay, because yes, but okay. So this is also large groups, also this is also a chelating groups. So for Crumb's chelate model, that chelating group should be seen to this carbonyl groups. So the same things we have did here. This will be the seen to this carbonyl groups, but now the attacking of the reagent will be from the small group side, not from the medium group side. Medium group side is for that Crumb's model, but for anti-Crumb's model the attacking will be from the small group side. So here that attacking of the reagents will be from that small group side, and small group side is here the right. So this is going to be that OH, and this is going to be the H. Okay, and here also just make it, after that this will be same. So this is going to be the OH and this is going to be the H. So this is the answers for if it follows the Cram-Stillett model, if NaBH4 and CaCl2 metal is given. Okay. Now we will move to the next questions, that is option C. For option C, what is there? Butyl MgBr. This is a Grignard reagents and this is negative and this is the positive. Okay. For this case, reagent is this. Okay. So now what you see that this the unsaid lone pair is here. With that, this magnesium, this show the chelating property. So here we will use that Cram-Stillett model. So what the model says that this group has to be the syn to this carbonyl groups. For that, what we will do? So first make this. This is Me and this is Me and this is C7H15 and so this means always left, means below, and this is always right. So make this accordingly. So here will be that same things that has mentioned OM and this is H. Okay. Now what that this for Cram-Stillett model, this has to be the syn to this carbonyl groups. So to make it to the syn, what you do that, just rotate here and rotate this and rotate to this. Okay. So after rotating, what you will get? This methyls and this OMe will be going to this sides and this H, this C7H7 will be here and this H will be this side. Okay. Now that attacking of that reagents here, that butyl will be from that small group side. So small group side is at the right. It means it will be from the front side. Okay. From the front side, it means this methyl, and this will be from the right. Right means here this, and this is going to be here OH, and this is OM, this is C7H15, and this is going to be the H. Now make this to this original forms, it means and this formats. So because in the answers this will be in the same way. So after doing this, after making this, convert it into the original form. Okay. So this will be going to be that. Here is methyls, and this right means this front, and back means left means this below, and here will be that C7H15s and H OM. This is the final answers for these questions. Okay. So similarly way we can solve that D questions. Okay. I will erase it. For these questions you see that to this alpha carbons of these carbonyls, here that lone pair is there, but here one is phenyl and one is methyl. So in this case this lone pair able to do the chelate, because this is not so bulky, so now it will do the chelate. So this again it will show that Cram's chelate model. Okay, if both are phenyl, on that case this lone pair not able to do the chelation property, but if one is phenyl and one is CH2 simply, then in this case it will do that Cram's chelate model. So it will able to do the chelating, and metal also magnesium is there which show the chelating properties. So it will it satisfy all the properties of Cram's chelate model. It satisfy all the conditions of Cram's chelate model. So here we again do the Cram's chelate model. So Cram's chelate model, what it says that this group has to be seen to these carbonyl groups. Now it is again same way, it already shown that this is seen to this carbonyl group, so we no need to change, or simply we just change that, because we know that this means right and this below means left. That only you have to change here, because this is already in the seen to this carbonyl groups. Okay, so this is methyl, and this H will be here and this methyl will be here, because this represent that right and this represent that left, and here the same. So here this is already in the seen to the carbonyl group, so you no need to change. Okay, now what attacking of that will be that Cram's chelate model from the small group side. For Cram's model, that large group seed attack from the medium group side, but for Cram's chelate model the chelating groups should be seen to carbonyl groups and attacking will be from the small group side. So this small group is right side, so that is above side, so attack will be the above side. So same things we will do here. So attacking will be from the above side in the sense here this side attack will be there, and in this case that this will be there, and this is going to be that OH. Okay, and this is methyl, and after that this remain as it is. This is already in the same, and this whatever you see they mention the same things. So H is this side and methyl is this side. This is the final answers for these questions, or question D. Okay, so similarly we will solve that now question number E. So E is also very simple questions. What is there here that here we have this group is like this, here we have that CO, and here we have that OH. So this is the carbonyl groups, then this alpha, here we have the stereochemistry. Okay, so one is this, we know that this is always left and this above side is right, so make this, so this is already in the right position, so same thing we will here, this is H and this is NH2. Okay, now here again the stereochemistry is mentioned here methyl. So now what you will do that in this group first is BnBr2. BnBr2 means what it means, that is CH2 phenyl groups. This is what that BnBr, sorry, this is the actual group. Okay, so for this case what you will do that this is have that lone pairs, and here we have the lone pairs, here also we have the lone pairs. Now the question is which will attack this. Okay, so now this is less electronegativity and this is more electronegativity, so this less electronegativity will attack this here and this will be removed here. Okay, so that will be going to be that Here we have that methyls, and we have that COOH, and this, here we have that H, and here will be that N, and that is going to be the CH2 phenyl groups. Okay, and it get positive charge here H and here H, and it get positive charge that is fulfilled by one lone pair, so that is get removed. This is going to be the this. Okay, now this is already used. Again, two equivalent is there, so another times it will attack, and then again we will get that here CH2 and phenyl groups. So now what it become, that here lone pair is there again, but this lone pair become again a, this become again a bulky groups. So due to this bulky groups, this lone pair again not able to do a chelate. Okay, now you are giving that lithium aluminum hydrates. So even if here lithium aluminum hydride show the chelating properties, lithium will show the chelating property, but still it will not do the chelations with this. Okay, now if we are giving this lithium aluminum hydrates, so lithium aluminum hydride, another characteristic is it reduce this acid to a alcohol groups. So it will reduce it also. First reduce it methyls, and this is going to be that CH2OH. Okay, and this is going to be that H, and this is going to be this N, and this is CH2 phenyls, and this is also CH2 phenyls. Okay, now this is already reduced. Now what you say, that again we are doing that oxidations. Okay, now we are doing again oxidations, means this alcohol is going to again oxidize to alcohol. If you do that oxidations, then it again convert into either aldehyde or acids. If it is converted to aldehyde, then it is again going to convert into the acids. Or we can do this question number E in the next class. Today after this, in next class we will solve more. Okay, due to the time, I am stopping the class today.